Namaskar, hello everyone and welcome to my YouTube channel. How are you all doing? Great? Have you ever pretended to be sick to your boss? No. Boss को बहाना बना के छुट्टी ली है कभी? नहीं? Thereafter, have you ever been in a hot air balloon? What if you see your boss standing on the ground and waving at you? And in excitement, bewilderment, frustration or whatever you call it, you drop a stone from the balloon. Now that's interesting. So let's be specific here. Your hot air balloon is going up with a uniform velocity of 5 meters per second. If the balloon was 50 meters high when you did this drama of dropping a stone from the balloon, you have to tell me what are those 3 magical words that your boss is most likely to say to you. You are fired. Okay, let's talk physics here. So can you tell me the height of the balloon when your stone hits the ground? Let me give you 4 options. A, 58.5, B, 68.5, C, 78.5, or is it D, 98.5? Specific options for specific question. Sophisticated specific question. Take some time to find the answer and write your answers in the comment section below. I have a sore throat today. So what will be your answer? Let's do some physics here. I hope this looks clean. So these 2 things are known to me. Another thing that I know is the acceleration due to gravity, G. It is 9.8 meters per second square. You can also analyze this as 9.8 meters per second. You can write it like this. How can you interpret this? So, because of the gravitational pull of the earth, if you drop anything near the surface of the earth, it will always fall down because of the gravitational pull of the earth on that object that is having mass. So if this is the case, you can expect the velocity of such an object to be changing with the time. And how that velocity changes with the time, which quantity is the measure of this thing? This is the acceleration. That is, every second the speed is increasing by 9.8 meters per second. So if you drop something with 0 velocity, after 1 second, the change in velocity will be 9.8 meters per second. Thereafter, after 2 seconds, the velocity will be 19.6 meters per second. After 3 seconds, the change in velocity is 9.8 meters per second after 1 second. So this is the concept of acceleration due to gravity, which is also known as G, which is represented by G. So sometimes in problems, in order to make the calculations easier, the examiner will ask you to take G as 10 meters per second square in order to make your life easy, so that working with the problem is easier. But if you do not know the actual concepts, 10 लो 9.8 लो सब मोह माया है, हमें तो आता ही नहीं करना. Okay, so this is clear. These were the things that are given to you. You know that this problem is from kinematics. If you have watched my previous videos, we have discussed about kinematics in detail, and therein I told you that we have 3 equations of rectilinear motion, that is, motion in a straight line with constant acceleration, and depending upon what is given and what has to be found, you will be choosing one out of the given 3 equations. I repeatedly use this line in my every video. So let me write those 3 equations of rectilinear motion. V is equal to u plus at I hope by now you know that v is your final velocity, u is your initial velocity, a is acceleration, t is time. If you are a physics student, you ought to know this. And the displacement I can denote by s. This is initial velocity into time plus half acceleration into time square. And your third equation is v square is equal to u square plus 2as. So these are the three kinematic equations of motion in straight line with constant acceleration. So now I'll check that what is given in the question and what is my ultimate aim in this problem. So from here I can make one thing clear, that out of these three equations, my distance and velocities, these two equations seem to be working good here, but we are not sure how to proceed, either with this or this. So I think I will rule out this for the time being. Now third thing is to draw a rough diagram of the given situation, like you will be able to decide whether to proceed with this equation or this equation. The things will become easier. So let's draw the free body diagram here. So this is that balloon
from where the stone is dropped, and this is the boss, always angry, shouting for no reason. What they say is this uniform velocity of the balloon is 5 meters per second, and when this incident occurs, the balloon happens to be at a height of 50 meters, and g is the acceleration due to gravity. Do write what has to be found. To find height of this balloon when stone hits the ground.
So this is the initial sketch of the problem, like how the problem looks like. So if I drop a stone from here, so now let me think a little bit about this problem. If I drop a stone from here, from this balloon, if this stone will take some time to reach this ground, let that time be t. I do not know that time. So we will be finding out the exact value of this time using one of these three equations. So I can find out the value of time, because I think the distance is ultimately related to time. So in order to proceed with the problem, I make use of this equation. From this equation I cannot get the value of time. So using this equation, I want to find the time the stone takes to reach the ground. Now you can choose a coordinate axis. Here one axis is involved, that is the y-axis. You can choose the upward motion to be positive and the downward to be negative. So since the stone is going downwards in the downward direction, so wherever the things are going in the downward direction, you will be using negative sign with all those things. Fine. So here in this equation, S is the displacement, and you know that this is minus 50 meters in the downward direction. So this is minus 50 equal to initial velocity of the stone. Now this is another question. Now the question is to find this initial velocity of the stone. Now I told you that everything is relative in this world. Okay, now you need to know that in the question, the stone is in the balloon and balloon is itself having a uniform velocity of 5 meters per second, and you know that this stone is dropped from the balloon. The stone was earlier in the balloon and the relative velocity of stone with respect to balloon is 0. If you do not know this concept of relative velocity, I will put the links in the description box below. Do check the video out. We have discussed in great details, like velocity of something with respect to the other thing is velocity of one thing with respect to ground minus velocity of the second thing with respect to the ground. And if this 1 happens to be stone and this 2 happens to be balloon, this is velocity of stone with respect to balloon is velocity of stone with respect to ground minus velocity of balloon with respect to ground. So since the velocity of balloon with respect to ground is 5 meters per second, the boss standing on the ground is watching the balloon going in the upward direction with a uniform velocity of 5 meters per second. So from the ground, the velocity of the balloon is this, 5 meters per second. And the velocity of stone with respect to the ground is also 5 meters per second because the boss is watching the balloon, and if at all that stone is visible, if at all that stone is visible to this boss who is standing on the ground, that stone is also going upwards with a velocity, with a uniform velocity of 5 meters per second. That is the velocity of the balloon, and this means that the velocity of the stone with respect to the balloon is 0, because unless and until it was thrown, the stone was resting in the balloon. So is this point clear? Since you have to work in the reference frame attached to the ground, like what is the situation as narrated by this boss?
This boss has to do a major work, like he has to tell the other employees at work about this incident, and he has to warn others, like, do not get motivated by this person here. This time the stone falls on the ground, what if the other employees get motivated and the next time the stone might hit his head as well?
So we were here, so we have to work in the frame of reference attached to the ground. So this initial, I write it here, the initial distance of this balloon was minus 50, minus because we have to concentrate on the motion of the stone, and with respect to the stone at a height of 50 meters, this 50-meter distance is downwards. Okay, so initial velocity of the stone with respect to the ground is 5 meters per second in the upward direction. Note that signs are important. Upward direction is positive, upward y direction is positive. So if this is clear, so here this is plus 5 and you have to find out the time. Plus half acceleration due to gravity. Now this acceleration due to gravity is downwards and causing the motion of the stone in the downward direction. So this value will be minus 10 and into t square. So that's it. This is done. So if you understand the concept and you have written this equation with the correct signs, you will be able to find your correct time. So let us try finding this time. So you can see this is a quadratic equation in time t. So this equation is
5t square minus 5t minus 50, isn't it? Or you can write it as t square minus t minus 10 is equal to 0.
From here you will get the value of time. You know how to find time. This is minus b plus minus under root of b square minus 4 into a into c. I have simply applied the formula to find roots. This is the discriminant divided by 2a. What is a here? A t square plus bt plus c. This form, this equation is of this form. Discriminant is b square minus 4ac. This discriminant is this. So the value of time happens to be 1 plus minus under root of 41 divided by 2. Yes, seconds. So we have obtained two values of time that are these. One is this, other is this. Now you know that if you select this time with the negative sign, the time will come out to be negative. Like you have to find the time the stone takes to reach the ground, and this has to be positive. So the time that you will be using here is 1 plus under root of 41 by 2 seconds. So this can be ignored. I'm not interested in negative sign. Time should be real and positive. So the value of time is this. So this is approximately 3.7 seconds. If This is approximately 3.7 seconds. If you solve it, it comes out to be this value. So finally, what has been asked, you have to find out the height of the balloon when the stone hits the ground. So you know the initial height of the balloon is 50 meters and you have calculated the time that the stone takes to reach the ground. Now listen to me carefully. During this time, the balloon must also have traveled some distance. Now the stone, it is not abruptly hitting the ground like you throw it and it reaches there. So it is taking this 3.7 second time to hit the ground, and in this 3.7 seconds the balloon must have reached somewhere here, like this. In this time the balloon must have reached somewhere here. That means initially the height was 50 meters and you do not know this height. So if you want to calculate the height from the ground, the height of the balloon when the stone hits the ground, this additional distance has to be added in 50 meters in order to find the answer.
So how do we calculate this?
Again, S is ut plus half at square, and one thing that is given in the question is uniform velocity of balloon. Now concentrate on the motion of the balloon. Earlier it was the motion of the stone. Since the velocity is not changing with time, the velocity of the balloon is not changing with time, this acceleration will be 0. So S will simply be the initial velocity, that is 5 meters per second into the time, and this time will be this value because you have to find out the distance that will be covered by balloon in this very time, in 3.7 seconds. So this will be into 3.7 and this comes out to be 18.5 meters. So what will be your final answer? You simply have to add this 18.5 to this 50 meters and your answer is 68.5 meters. So what is the moral of the story? क्रोध को पालना सीख बेटा, विनाश काले विपरीत बुद्धि. When your boss waves at you, wave back at him. You have no other option, dear. गलती सिर्फ और सिर्फ तुम्हारी है. My boss, I love your voice. यही बोलना पड़ेगा बार बार. So I hope you liked this video and it was informative. I tried my best to explain the underlying physics concepts to you and I hope you were able to grasp something out of this. The ultimate aim of my videos is to develop some scientific temperament in all the viewers who are watching my videos, who watch my videos, all my subscribers, all those people who constantly support me and write the beautiful comments in the comment section. If you like my video, do not hesitate to hit the like button and I will be back with my next video. Till that time, you do not forget to take really good care of yourselves. See you all in my next video.